Hello everybody, this is Andy Pils and it's day 7 of Unit 8 on climate, and in today's videos I'm going to be talking about El Nino. In particular, I'm going to be using NOAA's interactive El Nino lab simulator, or the National Oceanic and Atmospheric Administration. So I'll show you how to use the simulator and how to progress through the 5 different levels. I'll read some of the instructions and go through some of the tasks. I won't be reading all of the information that's here just because I think that would make the video too long. So my advice to you is that if you're working along with me, watch me for one of the sections and then pause the video, read all of the information, and make sure you're doing all of the work that your teacher is asking you to do. So a quick introduction here. I'm going to move into level 1 right away. Again, please do read this background information, but this first level is going to be focused on just reading the map and how to interpret it. So we have lines of latitude, which are going to show the distance either north or south from the equator. We're going to be primarily looking at this area of the globe today, which is the Pacific Ocean. And the first couple activities are first going to ask us to identify lines of latitude and then identify the sea surface temperature at a particular latitude and longitude. So let's take a look at question 2. Lines of latitude, number 1, we just went over that. Should know that one. Question 2, according to the map, the average monthly sea surface temperature at 5 degrees north and 140 degrees west is approximately. I always like to find my longitude first, even though latitude is listed first. So I'm going to find 140 degrees west along the bottom here, and I find that value. So I know that my location is going to be along this line of longitude. Now I'm going to 5 degrees north. So if this big marked line is marking 20, then halfway between 0 and 20 degrees north would be 10 degrees north, about here. Then you figure 5 degrees north, oops, I'm on my wrong line. So 10 degrees would be about here, 5 would be about here. So here would be my point, about 5 degrees north, 146 degrees west. So if I use this scale here, I can determine the temperature. And to me, it looks like it's darker than this orange color. So I would say it's more than 24 and less than 32. So the only option that I could choose there, well, I could choose this 32 or 26, but I don't think that this spot is necessarily that dark. So I'm going to go with 26 degrees Celsius, and let's see how we did. We get it right? I think we got it right. We can move forward. I don't know why this isn't showing me the answer. Okay, now we're going to be looking at data over a long period of time, because when we're talking about climate, we can't just talk about daily weather. We need to see patterns of weather over a long period of time. So first, in this second part of the activity, you'll look at the data from just 2 months. So one is going to show us data from December 1990. That's here. And then December 1991, you're going to see a slightly different pattern in the sea surface temperature. So go ahead and answer that question based on what you see. And then, oopsie daisy, let's zoom back in here. The last part, which I really appreciate about this map, is we can see data from an even longer period of time, which starts from 1981 and goes to the present day. So if I click this little reset button, it does have some controls here. I like to show it in double speed, and then we can start to see this pattern of how the sea surface temperature changes. So we're going to, let's look over here in the Pacific Ocean again. Let's see if there's any pattern that we see. Okay, try to pay attention to where the darkest colors are, especially along the equator. That's going to indicate where the highest temperatures are. And then as it gets a little bit more to that yellow and whitish color, you're going to see lower temperatures. So where are their patterns, and how does that pattern change from season to season? As this activity goes on, we're going to look a little bit more into the nuts and bolts behind El Nino, or the El Nino activity happening. So before I give any answers away, we're just going to keep on continuing to level 2. So here we go. So level 2 is going to talk about 2 different ways we can look at climate data in order to investigate El Nino. So again, if you're following along with me, I would suggest that you pause the video and go ahead and read this background data. I'm going to get right into the activities, which is looking at data from a line graph and looking at data on a map. So we can do a little bit of a warm-up and determine the sea surface temperature at these different longitudes. So if I were to do just 1 or 2, for example, 140 degrees east longitude, I would just follow this up, see where it intersects this line, and I would get a value that seems to be between 28 and 29. It looks like it's a little bit more than halfway, so more than 28.5. So I would say about 28.6. And when finding these values, you want to get as accurate and as precise as you can be. So let's look at 180. Again, I'm going to go up here. It looks like it's a little bit more than 30. This also seems to be the warmest point on the graph. So I would say about, I don't even think it's 30.1. So I would just put 30.0 because to me, it looks like it's nearly intersecting where those perpendicular lines meet. So you'll see that if I use this line graph, I get pretty specific and precise results for my sea surface temperature. If we were to move a little bit further down and then take a look at this map again, you'll see that this scale is not as precise as we could have been with the line graph. And in addition to that, in order to get these temperatures, I would need to actually use my vision and my matching scale. So if I were to look at, let's say, 140 degrees west here and along the equator, I get kind of that orange hue. I'm always bad about matching my clothes, but I would say it's about, I would say it's maybe about 22.5. Let's put that in here, 22.5. And now this is going to give me the graph to look at this data side by side. So if I were to use this graph, let's see what the true value was, and I'm going to go up. Looks like I was a little bit off for 140, so it's more than 24. I would say about 24.3. So part 2 is just investigating the pros and cons to looking at data in these 2 ways, and that's what this last part is going to be discussing. One advantage to using a map over a line graph. Well, one obvious advantage to using a line graph over a map would be the precision that we can get with our data. We can pretty much find an exact number. And if you and I were to both do it, we would get fairly similar results. We might not get exactly the same, but we would get pretty close. When we're looking at this map, we might not get similar results, but what we can see on a map are patterns and trends when we're looking at data, especially for like a large field area in the map. So that's it for part 2. Now we're going to move forward to part 3. Okay, we're moving up to level 3. Here is our mission. It's the winter of 2015. The water along the coast of California is unusually warm. Tiny red crabs that are typically common in the warm waters of Mexico are now washing up along beaches of California, which is further north. Are these observations the result of an El Nino? Your mission is to find out using data. So let's take a look at our simulator. And again, if you're following along with me, I would pause the video and read through your objectives in your background. But just to summarize what we're going to be looking at here, during normal conditions, we're going to see these trade winds, which are predictable global winds. They're going to move from South America towards Indonesia. There's my YouTube ads. And because of this, they're going to push warmer ocean waters from east to west, so over towards Indonesia. And then we're going to see cooler sea surface temperatures over here closer to South America. When an El Nino event occurs, we're going to get less trade winds. So they're either going to be weaker winds or they're going to reverse directions. That's going to decrease the upwelling, the amount of cool water getting to the surface near South America. and that's going to allow this warmer water to travel across the Pacific Ocean. So let's continue down through this worksheet and take a look at what we're looking for in this section. So during an El Nino event, we're going to see a change of where this convection cell is happening. So under normal conditions, we'll see the trade winds blowing the warmer sea surface towards Indonesia. That warm air is going to rise up and it's going to cause convection to happen in the atmosphere. And it's also going to cause convection to happen here in the water. As the warm water moves this way, it's going to create a void for the cool water to come up and towards the surface, where it will continue along that convection cell. During El Nino conditions, we're going to see the warmest area shift over towards the east in the Pacific. So where it was being created over here, now it's going to be kind of created in the middle of the Pacific Ocean, and that's going to create two convection cells, and that's going to change the weather that certain areas are experiencing across the world. It's going to change the amount of flooding, and it's going to change the droughts that we see too. So here's what it looks like in a diagram. This is what it looks like in a line graph. So during a normal year, again, we see the warmest sea temperatures kind of over here in the Western Pacific, close to Indonesia. And as we move closer to South America, just like it is over here, we're going to see the sea surface temperature decrease. During an El Nino year, the warmest area is going to be kind of towards the middle of the Pacific, with cooler temperatures to the west and cooler temperatures again to the east. So let's take a look at these two line graphs from December 2014 and December 2015, and let's see if we see that pattern that we had seen. So in December 2014, I see a high temperature over here at around 165 degrees east, and then the temperature decreasing as I move across. And again, so we're just looking at the Pacific Ocean over here, and here it looks like it's increasing to reach a high point somewhere towards the middle of the Pacific and then down. So I would say that this does match that predictable pattern that we would see during an El Nino event. And then the following December 2016, again, we're kind of back to that normal pattern of the higher temperature being over in the Western Pacific and then decrease as we go across the ocean.